Welcome to estimation. I've gone ahead and listed 4 possible situations where you might need an estimation versus an exact value. Talked about shopping, approximating a discount. If I earn an hourly wage and I want to estimate my earnings for the month or the week. Maybe I want to estimate how many miles I've driven where I really don't need an exact amount. Or maybe I need to estimate a number of teachers that are going to be required to accommodate a particular group of students. Those are all things where rounding and getting to get an approximation would be okay. So pause the video right now, and I want you to see if you can add some other ideas. Fill up your number 2, 3, and 4, and then I'll be right back. One thing that's really important is you have to round first when you're making an estimation, and then add, subtract, multiply, or divide, whatever operation the situation demands. If I add, subtract, multiply, or divide first, and then I round, well, that really doesn't do me any good. I could have just gone ahead and used the exact amount. So I've got an example here. I'm asking you to estimate, get my pen working here so I can point, estimate the amount owed for a purchase for these items. So I don't want to just add them up the way they are, but notice how I'm showing my work here. I've listed the numbers in the problem. If I want the total, I take my amount for the binder, my amount for the stickers, and my amount for lunch. And then all of a sudden I'm using a symbol you may or may not have seen before right here. It's like the wavy equal, and it means approximation. It's important to use proper notation in math, because if you put an equal sign, it's really not true, because it's not equal to 5 plus 2 plus 22. It's approximately equal to 5 plus 2 plus 22. So I've rounded each one. And in this case, I rounded each one to the nearest whole number. And then 5 and 2 is 7, plus 22 is 29. So since it's a word problem situation, I've put a dollar sign with my answer, and it's approximately $29. Let's move on to page 2. So I've got another example here, and on this example, we're estimating a total number of students if there's 5 classes of 37, and then 6 classes of 21, excuse me. So I'm using a notation here you may or may not be familiar with. I'm going to try to get, sorry, excuse me there, I was trying to get rid of, there, that's a little bit better. You might not be familiar with these parentheses for multiplication, but if I want to multiply 5 times 37, and I do because I have 5 classes that all have 37 people in them, then the best way to do that is to use the parentheses. We're going to try to avoid using the X symbol for multiplication as much as possible. We talked about that in the last unit. Right here, we've got 6 times 21. So underneath, you're working down, showing your steps that way is important. I've put my approximation symbol because right now I'm rounding 37 to 40. I have rounded it to the nearest 10, and then I rounded 21 to the nearest 10. 5 times 40 is easy to do mentally. 5 times 4 is 20, and then I throw on a 0 because it was a 40. 6 times 2 is 12, and then I throw on a 0 because of the 20 here. 200 plus 120 is 320. If you need to do some scratch work, this is what we call showing the steps. The scratch work could be out to the side or on another piece of paper even. So I've worked it another way over here, solution number 2. take a look at it for just a minute. Try to see what is different. Compare the work for solution 1 to the work for solution 2. Just look at that for a minute. Because 5 times 40 is 200, it was just as easy for me to leave the 21 as 21 to multiply, because 6 times 1 is 6 and 6 times 2 is 12, and it's very easy to add 200 and 126. It seems like this might be more accurate, but let's just see. So I've come down and done a solution number 3. Here I'm working out the exact amount. Just because we're trying to see a little bit about the estimations that we made in part 1 and 2. So if I just multiply 5 times 37, now you can do that out to the side, but here's what I'm thinking when I'm doing it. Let me get a little marker here to show you. I'm thinking 5 times 7, that's 35, so I'm putting my 5 here. Carry the 3, well, that's not showing up very well on this video, so let me just say, if you need to do it out to the side, feel free to come over here and write out your 37 times 5. I'm really new to the video making thing, so I'm trying to get a little bit better. So I'm carrying my 3. I've got 15 plus 3, that's 185. But if you can look at it right there and get 185 multiplying it without doing work, what I call scratch work out here, that's totally fine. In fact, I encourage it when it's simple multiplication like this, but that's an individual decision. So I think of it as 6 times 1 and write my 6, and 6 times 2 is 12. And then when I'm adding these together, I think of it, you can write it out to the side. I think 100 and 100, that's 200. 80 and 20, that's another 100. So now I've got 300. And then 5 and 6, and that's 11. So I'm adding my hundreds together, my tens, and then my ones. So this is exact, so I use the equal signs. When I scroll down a little bit here, we can see that solution number 1, this 320, is actually closer to 311 than the 326. Why do you think this one worked out to be closer? Let's scroll back and take a look. Think about that for a minute. Pause the video and then come back. Well, I hope you came up with something, or at least an idea. Over here in solution number 1, trying to point to it for you, I apologize, right here. Solution number 1, we rounded 37 rounded up, and 21 got rounded down. Over here in solution 2, we rounded up and then kept this the way it was. So solution 1 came out to be a little bit closer because rounding 37 up to 40 and then rounding 21 down to 20 is sort of balanced each other out. So let's just say here in solution number 1, in solution 1, one value was rounded up. One value was rounded up, while the other this is harder than you think. While the other was rounded down. put comma there, balancing out. The thing you have to remember about estimating is everybody's estimate is not always going to come out to be the same. So on this next page here, we've got just some rules, but I put here there are not must-use rules regarding what place to round when estimating, but the following guidelines will help you get close. I need to amend that. So when adding or multiplying, I put these are best buds. Multiplying is just repeated addition. So these two are good friends. When you're adding or multiplying, if you round one of the values up and the other one down, you'll get a better estimate. To help remember that, I put think A for add. And you need alternate arrows. So like one up and one down. And it doesn't really matter which is which, but think A for add and the word alternate. So why does it work? Well, suppose we were adding 55 and 47. The exact sum is 102. If I round them both up to 60 and up to 50, I get what's called an overestimate. It's too big. If I round both of them down to the nearest 10, then I get an underestimate because it's too low. But if I do one of each, like if I round 55 down and 47 up, they both are 50, and again I'm rounding to the nearest 10, I get 100. You can see how 100 is closer to 102 than either the 90 or the 110. Now, anytime you need to pause to take a minute to think about something more, please do. Let's keep going with this idea. So looking at your next page. So when I'm subtracting or dividing, these are best friends because dividing is just repeatedly subtracting. So for this one, just think S for subtract, and you need the arrows to be the same. So A for add, alternate, S for subtract, same. So you either want both of them up or both of them down. So I did the same example over here, except the exact difference is 8. So if we do one of each, if I round 55 down and 47 up, I get 0 because they both become 50. If I round them both up, I get 10. If I round them both down, I get 10. So either one of those gives us a good estimate. Again, I just can't reiterate enough how everyone will not have the exact same estimate. So you need to keep that in mind when you're checking your homework and if you're working with a partner. So for practice, I want you to work, these are problems from your book, page 8, 14 through 27 even. Please ignore the directions given in the textbook and just use the rules that we just talked about with the alternating or same arrows to find the estimate. So I want you to show steps like I did over here. You don't have to work it multiple ways, but you want to work down and make sure you're using the approximation symbol when appropriate. So go ahead and pause the video and maybe just try one and then turn the video back on and we'll practice it together. Or you can work them all and then click back into the video. Good luck! All right, let's start with number 16. Let's say, remember I want to be able to do my math mentally. So I'm going to round, it's subtract, so that's S, same. So I either want both down or both up. Well, I'm going to round them both down because this is closer to 6,000 and this is closer to 3,000 than it is to 7 or 4,000. So, whoops. So let's just put a D here for down. So I'm going to round both of those down. Well, if I round both of those down, I will have what? 6,000 minus 3,000. Which is approximately 3,000. Apologize for the poor handwriting there. It's harder to write on here than you would think it would be. So, if you're just now checking that one, pause the video again and then try another one. Okay. Well, I just realized I didn't put a number 17 on here, so my numbering's a little bit off, but that doesn't really matter. Can't get my cursor where I want it. Let's try number 18. All right, right here. So think about this one first. I'm going to put my wavy equal sign. I look at both of these. It's add, a, alternate. So I need one up and one down. Well, it doesn't matter which way you go. I'm going to do this one up, and I'll just put arrows this time, and this one down. So if I round this one up, let's round to the nearest 1,000. This would round up to be 11,000. The next one would round down to be 4,000. And so my approximation comes out to be 11 and 4 is 15,000. Now, if I rounded them both up, I would actually, in this particular case, get a better estimate. This is okay. The reason being, both of these were really close to, like this one's super close to 11,000. So when I rounded this one down, it threw it off a little bit more. So it would have been all right for me to round both of them up as well. And I would have actually gotten an estimate that's a little closer to this, really. So either way would have been all right. Let's tackle number 20. 20 is similar. It's adding, so we think alternate. Now this time, if I round one up, I'm going to round this one up and this one down. And the reason I'm doing that is this one is closer to rounding up than this one. This one's super close to 17,000. So if I round this one up to 39,000, okay, I have no idea why the color just changed, but let's just roll with it. And now we're back. Okay, I must be hitting something. And this would be 17,000. And, oops, forgot my approximation symbol. And this is approximately 56,000. Let me tell you how I got that so quickly. And we're boxing our answer. Here, I'm thinking 30 and 10. So 30 and 10 is 40. And then 9 and 7 is 15. So, or 16 rather. So 40 and 16 is 56. And I already know it's all thousands. This one is similar. It's an up-down because A for add is alternate. So if I round the first one down and the second one up, and the reason being this one is closer to going up and this one is closer to being rounded down. So I'm going to do this one down and this one up. So if I round that, and on this case, hopefully you rounded to the nearest 100,000. That would make the mental addition a little bit easier. But again, there's no hard and fast rules all the time regarding how you estimate, like what place you round to. So I would round this to 600,000. And this one, if I round up, I would go up to 300,000. And if you're having trouble rounding, you might want to go back and review section 2.1a. Well, 6 and 3 is 9, so that gives us approximately 9. Excuse my little extra marks there. 900,000. And then let's box it. So if you haven't tried the last one on your own, let's pause it and try it. Before we do number 24, I didn't talk very much or at all about number 14 over here. So if you'll look back over here at number 14, can I get a little red marker here? At this one, I did it several ways. Here, notice it's subtraction. Subtraction, same. So I rounded both of them up, and I got 500. If I rounded both of them down, here, 700 and 200, I got 500 for my estimate. But if I rounded one up and one down, I actually got a better estimate. And I wrote a little paragraph here telling you why. The last one actually comes out best, even though it goes against the rule that I gave, and that's just because 797 is super close to 800. And no truer words have ever been spoken than this right here. Math just gets messy sometimes, and that's okay. It's not always hard and fast rules. So you just have to think a little bit, and remember, estimates are just that. They're not exact. All right, let's kick out this very last one, and we'll keep our red color. So you see the S for subtract. So you should think S, same, okay, I either need to round them both up or both down. Well, if I round them both up, I could do, or I could round them both down. It doesn't really matter. It turns out, even though they're both really close to rounding up, if I round them both down, I really get I get a similar estimate. But if you want to round up, this would be, if you rounded this up, it would be 1,000,000. That's 6 zeros. Kind of got it written pretty largely here. If I round the second number up, it would be 101,000. So minus 101,000. I'll just kind of do a little vertical subtraction here, and I'm only doing that because I've run out of room over here. On your paper, you really need to write it horizontally and not vertically. But think about this. They're both thousands. You really just need to subtract 1,000 minus 101. Well, what's 1,000 minus 100? 900. So if you subtract another 1, 900 minus 1 would be 899,000. And that is our approximation. If I rounded this one, the first one, down to 998,000 minus 100,000, then it would have been a little easier math to do. I would have 898,000. Both would be fine. All right. Well, good luck with your homework. Jump in and don't be afraid to make mistakes. That's how math works. Bye.